Let's take a look at exactly what we are going to cover in this video. I'm going to deep dive into some of the advanced Nmap scanning techniques, specifically focusing on how TCP flag interact with the target ports and firewalls. First of all, I will talk about some of the classic stealth scan, like for example the NULL scan, the fin scan, and the XMAS scan, and how they work by manipulating the TCP flags and why they are usually blocked by the modern firewall these days. Next, I will move on to the firewall and state detection. Like I will break down how you can use the ACK and Window scan to map out the network rule and the filter states. And finally, I will talk about some of the more advanced evasion technique. I will show you exactly how you can create your own custom scan using specific flag that we have talked about earlier, and how you can use the decoy scanning to spoof your IP address so that you can hide your tracks from the logs. So without any further detail, now let's get started. Okay, so first of all, what we're gonna cover is look at these different scan type: the NULL scan, fin scan, XMAS scan. These are historical, like used to work back in days when there were no strong firewall, not stateful firewall, and instead of it used to work on stateless firewall, like passing the packets through that, right? And it actually used to work, but nowadays we have the stateful firewall and it is not very important. It is just nice to know. Don't like it, we don't use it actually. And another category we have is the nice to know, like just you know better how this work. Still these are not, does not even we use these, but the important one that must to know and we use on a daily basis when you are doing map port scanning and network mapping, you have to know about the sync scan, TCP connect, UDP scan, and the version detection, operating detection, system detection, and the NSE script, right? So what I'm going to do from now is I will just give you overview about these three scan, then we will talk about this in a bit more detail. Okay, and I have already covered these three in the previous video. If you have not watched that, I will recommend checking it out first. And in the next video I will be talking about these two, the version detection and the operating system detection, right? So let's start from the null scan. Null scans basically send the TCP packet with zero flag. There is no flag. Remember I talked about in the previous video that we have the sync flag, the acknowledge flag, and the urgent flag, push flag, and there are two more, right? So basically it send the TCP packet with no flag. There is no zero flags are set, not a single flag is done on the packet. Is just a raw TCP with nothing in the flag field, right? So this is technically incorrect. In the normal communication TCP, when you are using TCP, it will not send the packet, it will not send a TCP packet with zero flag, right? It will have to send with some packet, some flags enabled, but this here is technically invalid. So what happens is that when a packet arrives at the port with no flag set, so if the port is open, the system ignores the packet and send no responses. But if the port is closed, it will send the RST packet, and from that Nmap can report it out that yeah, either the port is open or the port is not open. So that's pretty much the overview of the null scan. Okay, now let's talk about the fin scan. The fin scan send the TCP packet with only one flag set, which is the fin flag. The fin mean the finish flag, that which says that I'm done sending the data and now we need to close the connection. So it send the fin TCP packet with the fin flag set. And you know, when there is no connection, any established connection, and you send a TCP packet with the fin flag set, it is very unusual. Actually, the fin packet is very identical to the null's packet. When it goes to the port, and if the port is open, it will just drop the packet and it will send no response to the nmap. It will just get quiet and give you no response, and from that we can identify that yeah, the port is open. And if the port is closed, it will send the RST packet, just like the null scan. The way it is very similar, but it used to send TCP packet with zero flag, and this send the TCP packet with the fin flag enable, right? This output will be very identical as well. Now let's talk about the XMAS. Now with the XMAS, what happens is that in the TCP packet we have the three flags enabled. One is the finish, another is the PSH, and another is the urgent. If you remember, I talk about that fin means when the flag is enabled, it means I am done sending the data. I want to close the connection. PSH or push mean that send this data immediately to the application. No, you don't have to wait. And the third flag we have is the URG or urgent flag. This means when this is enabled, it means that this is urgent and this data is urgent and processes immediately, right? So in normal TCP communication, these three flags together won't be enabled because these are very unusual. It's like saying that you will not say at the same time that I'm done sending the data and push the data, and this second flag mean push the data to the application immediately, and then also send that this is urgent processes immediately. Like you are saying at once close the connection, process this data, and send the data to the application immediately. This is very unusual. So again, what happens that when you do this type of scan, you will see the result very identical to the NULL scan and the fin scan. If the port is open, it will drop the packet, ignore the packet, and send you no response. And from that you can find out that yeah, the port is open. And if the port is closed, you will get the RST packet. And from that the Nmap can report it out that the port is closed. So I hope you get the a very broad idea of these three scan. It is not very important to get in very detail. Another scan type we have is the Mammon scan. These are nice to know. I have told you at the start of this video. What this does is it send the TCP packet with the fin and acknowledge flag enabled together in the TCP packet. So it has specific meaning. It's like saying that we are done. I'm done sending the data and I want to close the connection. And the another side, the receiving side, will be like, yeah, I have also received all of the data you sent, and let's just close this connection. So this is what it means. And because of this specific two flags, when you enable in a TCP packet, what happens that when it goes to an open port, it actually drop the packet and send you no response, and which means it tell you indirectly that the port is open. And if the port is closed, it will just indirectly and if the port is closed, it will send you the RST packet. Very similar, very identical to the other scan that we have just talked about, but the thing is it send the fin plus acknowledge a flag, right? And when researchers figure out about this, they figure out that this can be exploited, so they literally correct this. And now both open and close port, when you do this type of scan, both the open port or either the closed port, both will send you the RST packet instead of like dropping your packet and letting you know that the port is open. And it's very impossible now to distinguish between the open and the closed port, right? So this is again another scan type that used to work before. Another type of scan we have the ACK scan. I have talked about this already in the previous video, but let me just tell you again quickly what this means is it actually send the ACK packet instead of the sync packet. Normally when you are using the TCP, you will have to send the sync packet in order to establish the connection, and when you send the data to something, they will like send you the acknowledge packet back. uh, but first you have to send the sync packet. But in this specific type of scan, you first of all send the ACK flag, and this is very unusual because there is no any established connection. And when you send this ACK flag, the system kind of respond with RST packet back to you whether the port is closed or no. And from that, first of all, the reason of this scan type is not to find out if the port is open or no. It's the purpose of this is to find out if there is a firewall or no, and what specific ports does it taking care of and what's not, right? So for example, over here we send the TCP, we send this ACK scan to any port whether it's closed or no. You will send the RST packet. But what actually tell you that about the firewall, as I said, when you get the RST packet back, when you do this, when you target a specific port and get back the RST packet, it means that the port is unfiltered. The firewall actually is allowing the traffic to reach that specific port. But if you target some specific port and you don't get any response back, and instead the nmap just gets timeout, means that the port is being filtered by the firewall, and it is not allowing any traffic or connection to that specific port, right? So that is how the ACK scan work. I hope you get the idea. And this Windows scan is very identical to the ACK scan that we have just talked about. When you send the ACK packet and it if it gives you sendbacks you the RST packet, what happens that in the ACK scan it doesn't really tell you whether the port is open or closed, but what actually happened in this Windows scan, it tells you that whether the port is open or no. And here is how it tells you exactly. The RST packet that you receive contains a field called the TCP window size, and under some operating system, if the window size in the RST packet is non-zero, it means that the port is open, and if it is a zero, if the value of the window size is zero, it means the port is closed. So this specific actually scan the TCP window size inside the RST packet, and based on that it tells you whether the port is open or no. Okay, so if you want to do this, can you have to use just the -sw, and like for example nmap sw and specify the target, or you can just specify specific port as well. And this is a custom scan. You have to create your own scan type, like getting together multiple flags based on whatever you want to test. Like for example, you can just write you can send the packet sync packet, RST packet, pin packet simultaneously in the TCP packet. And how you can do that is, these are the flags that I have talked about, and you can combine all of them, or either one or two or three, just whatever you like. You can just telling you, giving information how you can create you can create your own custom scan. And how you can do that is type the nmap and then the hyphen scan flag and specify the flags type, flags, and then your target. And this is how you can do the custom scan as well. And here is some technique to do the IP spoofing. Like for example, you want find out what ports are open on the target machine and target website or whatever you are targeting, and you want that you don't want to show your IP. So what you do is you just kind of add a fake IP or instead of your own IP. To do this, you just type the -s, which means IP address spoofing, and then you specify the IP address. You also specify the network interface as well. The problem with this is it will actually send the do the whatever type of scan you are doing on the target, it will actually do that, but the problem is that you have to get the response back as well. So now instead of sending it to you, it will send it to the spoof IP, and if you don't since it's not your IP, you will not get the result. So to do this, you will have to kind of get in the middle of this IP, so whatever traffics come to this, you also get that. It will kind of work like this, but we have a bit more better ways than this. For example, we have the decoy scanning. What this is, like, you specify multiple different IPs. First of all, you type the nmap, and then you also specify the target. Okay, and with the -d, what you do is actually you add multiple IP as a source IP, like not just one, not a single IP. You add like your own IP. Okay, this means my own IP, and this is some other IP, whether your friend's IP or some other IP, but must be real, right? So when you start this scan, what actually happens that the targets log show you that the traffic come from all of these IP addresses, and it's like telling that it's being attacking from multiple IPs at the same time. And over here you can see that a network analyst looking at the logs sees a flood of scan from different IPs, and because of that, it's kind of a bit gets harder to figure out who is the real attacker, what's the real IP. Though it's not impossible to figure out the real target IP, but it makes it a bit harder for them, right? And yeah, that's pretty much it for this video. I hope you learned something. There were no any practical stuff, but yeah, in the next video I will be covering about the version detection and the operating system detection scan. So yeah, if you have any question in any of these, let me know and I will get back to you, and actually I will see you in the next video. See you soon.